So relationship between loudness and intensity. What's the relationship between loudness and intensity? Let's see it. So although loudness of sound depends on an intensity, but loudness is not same as intensity. Okay. First you must remember this thing that loudness is not same as intensity. They are completely different quantities. Okay. Intensity is a measurable quantity. Okay. Intensity is a measurable quantity, while loudness is a sensation. While loudness is a sensation. Okay. It differs from person to person. It depends on the sensitivity of ear of the person. Okay. So experimentally, Weber and Freischner, there was two scientists. Okay, Weber, the name of the scientist were Weber and Fechner. They established a relationship between loudness and intensity, and it is given by L is equal to K log I to the base 10. This is called base 10. Okay, here the base of log is 10. Okay, so it is written, I mean pronounced as K log I to the base 10. Okay, so this is the relationship between loudness and intensity. Again, loudness is not same as intensity because intensity is a measurable quantity while loudness is a sensation. So there were these two scientists, Weber and Fechner. Okay, they came up with this relationship, which is L is equal to K log I, where K is a constant of proportionality, and obviously loudness increases with the increase in intensity, but not in the same proportion. Okay, because that is because of this log function. I'm sure you are familiar with this log function. Okay, let's move ahead. Okay, now units of loudness and sound level. What are the units and units of loudness and sound level? Phone and decibel. Okay, units of loudness and sound level, which is phone and decibel. The unit of loudness is phone. Okay, PHON. Unit of loudness is phone. Don't ever forget this. Okay, that the unit of loudness is phone. The level of sound is expressed in decibel. Again, the level of sound is expressed in decibel. its symbol is dB. Okay, small d and capital B. Let me write this here. It is D and capital P. This is decibel. It is the level. Okay, here unit is phone, but loudness represents the level of sound. Okay, so the loudness of a sound in phone is the loudness in decibel of an equally loud pure sound of frequency 1 kilohertz. So that's the relationship between phone and decibel. Let me write it again. Okay, that the loudness of a sound in phone is the loudness in decibel of an equally loud pure sound of frequency 1 kilohertz. This is 1. Okay, the loudness of a sound in phone, that is basically one phone is equal to what? So one phone is equal to loudness in decibel of an equally loud pure sound of frequency 1 kilohertz. Or in other words, the sound of 1 kilohertz frequency, which is a pure sound, that is equal to one phone. Okay, again, what is phone? So one phone is equal to loudness in decibel of an equally loud pure sound of frequency 1 kilohertz. So here it is equal to pure sound of 1 decibel, or you can say 1 decibel pure sound. Here it's not working, I don't know why. Okay, so 1 decibel of pure sound having frequency 1 kilohertz. This is the relation between phone and decibel. So again, phone is the SI unit of loudness. Okay, and the decibel is level of sound. So thus both the phone and the decibel scales agree at the frequency 1 kilohertz. Basically at 1 kilohertz both these units, I mean, you are getting the same values. Okay, so again, from previous equation, the previous equation was L is equal to K log I to the base 10. So from this equation, if at a given frequency, let's say I1, given frequency, let's say I1 and I0 are the intensity of two sounds. Okay, these are the different frequencies of two sounds, of which loudness are L1 and L0. Here the loudness is L1 for I1 intensity, and loudness for I0 intensity it is L0. So we can write this equation for the given data, that here it is L1 is equal to K log I1 to the base 10, and here it will be L0 is equal to K log I0 to the base 10. These are the two equations, right? Okay. Now, if you take the difference, what happened? I don't know. Okay. So, if you take the difference, hence the difference in loudness of these two sounds is basically what? Loudness, right? Loudness is equal to L1 minus L0 is equal to, it will be K in the bracket log I1 minus log I0. Right now we are not writing log 10, okay, because we don't want to write it, but just assume there is that 10, okay. So according to log property says that if you are having this equation log a minus log b, you can write it this way, log a by b. So we are going to use this property of log, okay. It will become k log I1 by I0, right? This is our third equation. So if I0 is the minimum intensity, let's say, is the minimum intensity of, let's say, of the order 10 raised to minus 12 watt per meter square of audible sound, right, at frequency 1 kilohertz, then L is called sound level. Again, if I0 is the minimum intensity of order 10 raised to minus 12 of audible sound at frequency 1 kilohertz, then loudness L is called the sound level. Okay, if I0 is again, if I0 is the minimum intensity which is audible of an audible sound at frequency 1 kilohertz, then L is called sound level. Now in this equation, if you take k is equal to 1, L will become log I1 by I0, right? Yes or no? And this is in unit Bell, okay. Now remember, 1 by 10 1 by 10 Bell is equal to 1 decibel, okay. This is the relation. So we are going to use this relation, okay. So here L will be, if you multiply it with 10, it will become 10 log I1 by I0. Then we need to divide it with 10, right? So here it will become 10 log I1 by I0. And as we have discussed, 1 by 10 bell is 1 decibel. So this will become decibel, okay. Deep. This is the loudness in decibel in its purest form. Here bell or decibel is the unit of loudness level, okay, named after the scientist Alexander Graham Bell, who invented telephone, right? Inventor of telephone. So obviously for I1 is equal to I0, let's take this interesting case. If I1 is equal to I0, what will happen? Sound level will be what? L is equal to 10 log 1. It will become 1, right? Because I1 and I0 are equal. Now from the log properties that log 1 is 0, here loudness will be 0. So basically 0 decibel, right? Now let's say intensity increases from I0 to 100 I0. So in this case L will become what? 10 log 100. Now again from this log property that you can write it this way, that log 100 you can write it log 10 raised to 2, and you can take this 2 in multiplication, so it will become 2 log 10. Log 10, the value of log 10 is 2. Okay, this is 100. This is log 100. So this will become 10 multiplied by 2, which is 20. So here the loudness becomes 20 decibel. Okay, so this is just a simple calculation. Okay, so let's define 1 decibel properly. Its scientific and pure definition. So thus, 1 decibel is defined as the change in level of loudness when the intensity of sound changes by 26%. Again, 1 decibel is defined as the change in level of loudness when the intensity of sound changes by 26%. How it changes 26%? We'll discuss it later. Okay.